So let's start talking about graphical user interfaces or GUIs. A GUI could provide an easy-to-handle interface to the users of your programs, for example by having a graphical window with push buttons, text input fields, sliders, radio buttons, etc., with which your users can interact. Most operating systems we are using today are windowing operating systems, and as such lend themselves for designing GUIs with relative ease. Programs with GUIs have a different working paradigm than what you are usually used to based on your homework programming experience, where you have a main function with which you implement algorithms using for and while loops, if statements, etc. We will see that programming GUIs will require a somewhat different mindset. However, even with the help of windowing operating systems, the sheer amount of raw information that the OS could provide to the GUI programmer could be overwhelming. We are talking about receiving keyboard and mouse information in a raw form whenever a GUI is highlighted in the operating systems, and changing various pixels inside the window for displaying purposes. GUI libraries can help with that pain. They form a layer between your GUI code and the operating system, providing you a much higher level interface. Using GUIs will allow you to easily put constructs such as buttons, text input fields, sliders, pictures, etc. in your window, and to be notified if the user interacts with any of these constructs. GUIs are event-oriented. Once you design your window with the buttons, input fields, etc. in them and start your program, how will you know that a user actually interacted with them? Users will interact with entries in your window, and each of these interactions will create an event. Events such as pushing a button, grabbing a slider, etc. You will have to provide and register functions that the GUI library will call when each of these events happen. Functions like these are called callback functions, as they allow your code to be called back from a main library. Once the user interface is built in the main code, we will have to turn over execution to the GUI library's main loop. From then on, this main loop takes over and calls your callback function if an event happens. Let's talk about the word widget. In a GUI window, you would place all kinds of items that users can interact with. These items are called windowing gadgets or widgets. Some common widgets are push buttons, sliders, radio buttons, etc. So how would you actually go about designing the interface? You could do it the hard way and do it programmatically by calling functions from your main code that place specific color and size buttons in the, let's say, top left corner at location 620 with the text click me, and do the same for all other widgets that you want to place in the window, for every slider, for every text input field, for every button. This is busy work with a lot of compilations and tests to see if everything looks just the way you want. The easier method is to use GUI builder tools. Visual Studio has built-in tools for the Windows OS, but there are other tools as well. Here we are going to focus on Glade, which is an open source GUI builder. In this lab, we are going to be using the GTK+3 library as the GUI library. The GUI builder Glade can then be used to create GUI designs. Glade will store the design in a human and machine-readable XML form, designating where each and every widget should go and what should happen, i.e. what function should be called if a user interacts with the interface. The most straightforward way to use GTK+3 and Glade is to load the interface definition XML file created by Glade at runtime. This means that the interface definition file must be available to the executable at runtime. For us, this means that we will have to have this XML file in the same directory as we are going to have our executable. Let us mention glib briefly as well. Glib is a set of libraries that can make programming GUI interfaces easier by providing access to constructs such as threads and mutexes. We are going to deal with this in a later lab. And on that high note, let's fire the pipe back up and let's first build a GUI with Glade, and once we are done with that, let's write the code around that, handling the actual user interactions. So what you see here is where we left off after CMake. So what we're gonna do now is, remember this code when we called it? It came up with this user interface of a very stupid calculator where we could enter a value for A, we could enter a value for B, and when we click the add button, it takes those two values and displays it under C. So the first thing that we're gonna do is we're gonna actually design a similar looking interface. So for that we're gonna be using Glade. And when we use Glade, Glade is gonna create an XML file with our user interface design, and you can name this file with a .ui or a .glade extension. So that was, if you remember, if we switch over to our source directory here, I already have a calculator.glade file here. I'm not gonna use this file because I wanna do it from scratch for you, but you see that there is already one. Let's quickly look into it, and you see that, oh yeah, this is indeed an XML file with all kinds of things in there. So how would you go about this? Well, the first thing that you will need to do is install Glade on your Raspberry Pi. How do we do that? We're gonna issue a command sudo apt-get install Glade. Enter. I already have it installed. You don't have it installed yet, so it's gonna take you a little while to get it installed. Once it's installed, it is actually gonna install GDK and glib and GTK and all kinds of other things that we're gonna need. So now that we have Glade installed, we can just start it up. We start it up by issuing the command Glade. I'm gonna put a %, at the end of it. That means run it in the background, so I get my terminal black. Here we go. Now we have this user interface designer tool started for us. So the first thing that we're gonna do is we're gonna say, okay, well, I want a window. So I'm taking a window, I click on it, here I have a window. I can rename this window, but it's okay for me for this window to be called window 1. So if I ever have to refer to it, I just have to refer to window 1. And let's look at some of these properties here of this window. There is general properties, there are packing properties, there are common properties to it, there are signals that you can attach to it. So this, we're gonna see that later. I mean, here, for example, signals are activate default. So if you move your mouse over this window, then you could type a function name in here that would be called. I'm gonna skip this now. We're gonna go back to general, and somewhere here we can actually give it a name. Here we go. How do we want to appear in the title bar? Let's say we want to make it our CSE 2100 window. I'm not gonna spend a lot more time on it because I actually want to focus on what goes inside this window. So in order to put things inside this window, I have to cut up the space inside the window. And that's what these containers are for. And let's focus on these first two. This one is a little bit more elaborate version. This only cuts it up vertically. This cuts it up, or rather horizontally. This cuts it up horizontally and vertically. So what did we want to have in this user interface? We want to have a text A column, then we're going to want an input field, we're going to have another text B column, another input field afterwards, and then we want to have the output, and we want to have two buttons, the add button and the exit button. So the first thing I'm going to do is I'm going to actually divide this window into three. So I'm clicking on this, dragging this over to the, or actually moving my mouse over to the window, pushing the left button, and now it's going to ask me, so how many horizontal divisions do you want to have? And I'm going to say, I want to have 3. So now you can see that it divided up my window in 3 horizontal regions. Now I'm going to go to the top one and I'm going to cut that up into 4 regions. So I click on this and I'm going to say I want to have 0 rows, well actually 1 row, and I'm going to have 4 columns in this row. And I'm going to create that. So now what you see is that this top horizontal region got cut up into 4 vertical regions. You can also see it here on this side. So I have a window. Under this window I placed a box, and when I click on that I can see that this box has 3 items, and under one of those entries into the box I have actually placed a grid that's 1×4. Okay, so now let's place some more important things. So the first thing I want to say is a colon, right? I mean, for that we would have to place a label thing. Oh, here we go. I have to pull this down. Label. I want to place a label here. Let me blow up this window. Here we go. So now I place the label in this very first container that we created. And I'm gonna keep the ID of the label, just label 1, but I want it to say a colon instead of label, a colon. And you can see that it has changed to that. Now I need a similar label in this container here. So I'm just gonna take label, put another one here, and I'm gonna call this, or I'm gonna make it display b colon. And I don't worry about what it's called, label 2 is fine. Now we want the user to be able to enter something, right? So we're gonna now include a text entry field. What's this? Text entry. Good, that's what we want. So I'm clicking on that, putting it here, and this is called now entry 1. And in this case I'm gonna rename this into entry A. This is how we're gonna refer to it from our code. And originally it should be empty. I'm not gonna go deep into detail with all these things that you can be setting. I'm gonna do the same thing for B. So now I'm gonna rename this to entry B. And you guys can see the hierarchy right now, right? So under window I divide it up into 3, that I divided into 4, and here are now these 4 entries in that. So the next thing I'm gonna do is I wanna display an output. So here, oopsie, we're gonna place another label. Where is my label? Well, actually we need to cut this up into 2 parts, the middle part, right? We're gonna cut this up into 1 row and 2 columns. 1 row, 2 columns, create. Now I have 2 containers in there. The first one I'm gonna call C colon, oopsie, right here, C colon, and I'm gonna have, I want to output next to it, right? The output is not a text input field. An output could be a label as well, a label that I want to be able to change from my code. So I'm gonna put a label here, and instead of it being called label 4, since I want to actually have access to it, I want to name it something that I can remember. I'm gonna name it label C. And finally what we're gonna do is we're gonna place 2 buttons at the bottom of this. One of them is gonna be our add button, and the other one is gonna be our exit button. So again, I will have to divide this bottom up into 1 row, 2 columns, and once I'm done with that, I'm gonna include 2 buttons. Button 1 here, I'm gonna call this button add, just so I can remember it easier. And what I want to say on the button is add. Here we go. And I'm gonna make one more button. That's gonna be our button exit. So button exit, and I want it to say exit. Here we go. So it's not a pretty user interface, but hey, it's a user interface. Somewhere here I can click on preview. I click on that. It takes a little bit and it says, oh, by the way, this is what you're gonna be getting. You could now go into the properties of each and every one of these widgets and change it so that it looks actually prettier. But we don't want to worry about that. We are not done yet. I mean, there are a few things. For example, this label, I have to come back here, and on this label, which is label C, I'm gonna click here, and I don't want it to display anything at the beginning. Well, actually, why don't we display a 0 at the beginning? Okay. So I am really not gonna care about changing this label or this label or this label. The only thing I wanna change is this label. When do I wanna change this label? When the user presses the add button, right? Do I actually care what's in this field or in this field? Do I wanna be notified when the user starts changing it? No, because the only time I'm gonna be interested in what they contain is when the user clicks on the add button. However, I have to know when the add button and the exit button is being pushed. So that's the next thing that we're gonna do is we're gonna click on this add button, and now we're gonna go to signals here. And on signals you can see that all these are the different events that can happen to this button. It can be activated, it can be clicked, it can be left, it can be pressed, released, and so on. But what we are interested in really is in the clicked. So when this button is clicked, I want to be notified. So I'm going to come here and I'm going to type a function's name that I want this to be called. For example, button add clicked. Okay, I'm gonna click somewhere else here just to make sure that it received it. Now I can see it's in there. I'm gonna do the same thing with the exit button. So I'm gonna click on exit. I'm gonna go over to signals. I'm gonna click on clicked, and then I'm gonna enter the function I'm gonna be using to handle this as button exit clicked. Okay, now I'm gonna say I'm done. This is my user interface. This is how I want it to look like, and these are really the two events that I'm interested in this very simple version. So I'm gonna save this file, save as. We're gonna call this CSC 2100 calculator. Here is my previous one that I have done on my own, but this is the one that we have done now. So I'm gonna save it here. Save. Okay, I'm gonna exit this so it's not a resource hog on my Raspberry Pi. Ignore these errors that you see on this terminal. We don't worry about that. But what we are worried about is here is our Glade file. That's our XML file. Hallelujah. Okay. So now all we have to do is write some code around it. And you guys see that I have already written some code around it. And instead of rewriting that like we did it with the user interface, I'm just gonna open up this main.cpp file and show you what's inside. And there is gonna be a bunch of mumbo jumbo here, and I'll explain that to you what each and every one of them is. But let's first go to the very end of this file. Well, not the very end, but somewhere towards the end, where our main function is. Here's our main function. And we're gonna create a variable because we actually don't want to create our own user interface in this code. We wanna use the design that we created by the builder. So for that we have to create a GTK builder pointer, and we also want to create a G error pointer. This is the way that GTK sends you error messages. Then we're going to initialize GTK plus, And when we initialize GTK plus, we have to give argc and argv over to that, meaning the main function's parameters with which it was called. This is for X to take advantage of the built-in handling of various X activities. Don't worry about it. Then we're gonna create an instance, a GTK instance. So we're gonna say, oh, by the way, create a GUI application. Now you don't see this, but this is a global variable. I know that you have been told not to or be scarce using global variables, but sometimes you have to use global variables. I'm going to show that to you that this is a global variable. I usually define this as global variables because then I can interact easily between different functions just by using this global variable. Then I'm going to establish the builder, filling out that pointer that we did. And here I'm going to say, now let's create, or let's load in my design that I had. And I'm going to change this. This was calculator.glade. I'm going to change it to our current one. What did we name our current one? CSE 2100 calculator.glade. Okay, CSE 2100 calculator.glade. If some error happened, I want to display it and exit the code. Just leave it this way. Now, the next thing for us to do is now that this has been loaded, we want to figure out what kind of widgets were included in there. So I'm going to call this obtain GUI widgets, which is a function that I've written. It's at the very beginning of this file. So what you see is, again, there's a little bit of a mumbo jumbo here, but there is a macro here, and this macro makes my life much easier. There's a macro that defines this GUI app-get function. Don't think of this, well, think of it as a function, but it's really a macro. It defines this macro with which I can now take over from that builder all these different widgets that I'm interested in. I can take over window 1 on a why not basis, right? Remember, guys, we called it window 1. I can take over entry A. I can take over entry B. We called this entry A and entry B, if you remember. I can take over button add and button exit. And I can also take over label C. So this is with which I can connect the builder, that XML file rather, with my code. So if I want to add more buttons, I can include them here. Not only that, but let me now open global.h, and you can see that in global.h I actually created a structure into which I can store these widgets. So there is a GTK widget for window 1, for entry A, entry B, entry label C, button add, button exit. I had to create this in order to be able to store the ones, and it's a good policy to name this variable the same way you named those widgets. Remember, the window was named window 1, the entry was named entry A. So I'm gonna associate with a variable in each one of these, well, a pointer with each one of these. And here is my GUI app variable, where a definition, a forward declaration of that variable into which I'm gonna create all of this GUI. So if I wanted to add additional buttons and all that, I would have to make sure that I also enter them here. And let me go back to main, that I also take them over, i.e. fill out those pointers with whatever comes from the GUI. So going back down here. So now that I took over the widgets that I need, I also want to connect the signals. Remember, for 2 of the widgets, for the button add and the button exit, we said that, hey, there should be signals. The button pushed and, well, the button add pushed and the button exit pushed. So what this line will do is it's gonna take it from that description and connect it to my function. So somewhere up here, you're actually gonna see two functions. Hallelujah, here we go. Button add clicked, remember guys, this was the name that I named my function, and button exit clicked, or my event. So there are functions in here that are named exactly the same way. Then, now that I processed everything from that builder, I may as well destroy that builder. I don't need it anymore. Now I have a user interface, and I want to display that user interface. I want to actually I want to make it appear on the screen, and this is why I'm taking window 1 over, because this is how I make it appear. And now the most important thing to do is giving execution over to the GUI library so that it can call my functions in me. After this call, I'm not going to have control of anything. I just relinquished control over to the library. The only time this is going to exit if somebody is going to exit the graphical user interface, and if that happens and if my application is still there, I'm just going to destroy it, because I'm a nice guy and I like to destroy my objects before I exit my code. So the last two things to look at is, let's first look at the function that I associated with the event button exit, right? We called it button exit clicked. If button exit clicked is pushed, what do I want to do? I'm going to call yet another GTK library function called main quit. Well, guess what this is going to do? This is going to quit the graphical user interface. More importantly, let's look at this function here, button add clicked. What that is going to do is, so what do we want to do when the add button is clicked? We're going to take over what entry A and entry B contain. We have to store them in two variables. We have to add them together and display the result or move the result into label C. And that's what this code is going to do. So I'm going to establish two pointers that I'm going to point to those two input fields. I'm going to establish a buffer into which I want to store the result. And I'm going to create two variables into which I let the user, into which I'm going to load the actual values in a double form, because I can't really add two strings together, right? So this is how you take a value over from the GUI. You use GTK entry get text. Since this is an entry, if this was a label, you would use GTK label get text. But since this entry uses GTK entry get text, you say, oh, by the way, this is a GTK entry. This is a built-in macro into GTK. But more importantly, this is the widget out of which I want to take it, right? It's the entry A. So what this line is going to result, it's going to make ACC value point to the text that's in entry A. And since it's a text and I want to make it into a double, I'm going to use the A2F function to make a double out of a string. I'm going to do the exact same thing about entry B. Now I have AD value and BD value, two doubles. I can add them together. I'm going to sort them in CD value, right? And once I add that and I want to display CD value, first I need to turn that into a string. That's what sprintf is used to. So in sprintf, the first parameter is into what buffer I want to put it. I want to put it into this buffer that I created. What I want to put in there? Well, I want to put a double in there. That's the %G. And what do I want %G to be replaced with? And that will be this double. So this is going to fill CCC value, that buffer, with a double in a string format. And once I'm done with that, I'm going to call another function in GTK, telling GTK, set the text in this label, GTK label set text. And here's the label in which I want to set it. It's a GTK label, and it's called label C. And this is the string to which I want to set it to. So that's pretty much it. There is one more thing that we probably want to look at. That one more thing is the actual CMake list file. Why is that? Because in order for me to use glib and GTK, I have to tell the compiler that it needs to look for that library, for the include files and the library files for that library. So let me go back to a terminal window. A lot of libraries that people provide are done so that it's easy for you to figure out what kind of compiler directives you have to provide. And the utility for that is called pkgconfig. So there is this utility called pkgconfig, and if I write the name of a library, so this is GTK Plus and the third version of it, and oh, by the way, these are all the include directories that you have to give to your compiler. And if I want to know what libraries I need to link, it's the -- libs flag, and it's gonna tell me, oh, by the way, this will be the libraries that you need to include when you're building. So since there is this utility pkgconfig, and it's hopefully installed on your Pi already, if it's not, you can install it with sudo apt-get install pkgconfig. I have it installed on mine, so it doesn't need to be upgraded. Now we're gonna be using this utility from within CMake to actually determine which libraries or which include directories we need to do. So again, nothing changes here. Include subdirectories, include find package. Okay, so the first thing that changes is this find package. So this find package command in CMake says, oh, by the way, use pkgconfig. And that's the package that I'm actually going to be looking for. I want to look for pkgconfig, and this is going to be required for me. This package is going to be required for me in order to be able to do a good build. And now that I have actually included pkgconfig into CMake, I can use pkg check modules, and what this will do is it's going to look for GTK plus 30, and if it finds it, it's going to make this variable signify that it found it. So this variable GTK pkg that I put here now is going to be extended with underscore found. If this variable is true, then that means that we found the GTK 3.0 library, and then that means that we need to include all the directories, and this would be the underscore include dirs. Let's see, what did I do? Here we go. And not only do we need to make all these directories be include directories, but we also have to make sure that we know what the link directories are. And these are the link or the library directories for GTK plus. If we didn't find the GTK plus 3 library, then we want to display that to the user and say, hey, this is fatal. You can't be compiling without those libraries. This thing is the same. Look for all CPP files in the source directory. Make an executable called calculator based on all of these sources. And link to your executable everything that needs to be linked from the GTK package. And this is the GTK pkg libraries. And at the end, your Glade file is going to be needed runtime, because your code is going to read that file. So what we want is we want the Glade file be copied over from the source directory into the build directory. So when we start our calculator, it will be there. So that's what these two lines do at the end. It copies all files from the source directory that are called Glade or have an extension Glade into the build directory. Okay. So with that, let's go back to the build directory. We're gonna do a clean build, so we're gonna remove everything from this build directory. We're gonna first invoke cmake, crossing our fingers. Everything is fine. We should have a make file. Let's invoke make, crossing our fingers. Everything is fine. So now we have a executable called calculator here. I'm gonna start it, and here we go. This is actually the user interface that we designed previously. So let's see if it works. 67 plus 23. Right now my function or my code wasn't called yet. The button add clicked is going to be called as soon as I push this, and when I do that, it calculated what the sum is and it displayed it in this 90, and then I push the exit button. I exited. So this was a very simple calculator. Your task is going to be to build a much more elaborate calculator, adding additional buttons, putting the handlers for that. We're going to be giving you a skeleton for this. So next, we're going to actually look at what I would like your project to resemble. So here we are on my Trusted Pi. You guys see that I have a real calculator directory. I'm in the build folder, making sure that this build folder is empty. It has. I issue the cmake command. Hallelujah. Make. And now I should have a calculator executable. Here we go. So this is what your task is going to be for today, to create a user interface of a calculator that somewhat looks like this. Please feel free to use your own design. We would just like to have 10 buttons for the numbers and the 4 major operations. If you want, you can include an equal. You don't necessarily have to an exit button. You can place them any way you want. If you want to include more, that's up to you. So let's say if you want to multiply 32, you guys see that pushing the 32 appeared. By 9 is 288 plus 12 is 300. So here's the code you're gonna get, and let's first build this calculator skeleton just to show you that it actually builds and you can actually run it. So we're gonna do a cmake dot in the build directory of it. Then we're gonna do a make. Compiled. Let's start it. So you see that all this does is it gives you 2 buttons and the plus button, and I can add 122 to 211 if I want to, and it gives me the results. So we want you to extend this to make it into a real calculator with the 4 main operations and all the numerical buttons. A few hints. First of all, you will need to extend the user interface. So you can load the user interface into Glade, and then now you can figure out how to extend this. Or if you want to, you can create one from scratch. So for example, here if I'm highlighting this, I could say, okay, so right now there's a 1x5. I would want to make this into a, let's say, a 5x5. So that way I can add more buttons to it. I'm going to exit here. And once you're done with that and you register the right callback functions, you wanna edit the main function. Here I'm giving you, or we're giving you, the handler for button 1 clicked, button 2 clicked. You want to do something similar for the rest of the buttons all the way to 0. And here's the exit clicked, and then here's the plus clicked. This one is the plus click. You can think about what it does. You also want to create, based on this, a multiply, an add, and a multiply, a subtract, and a divide button. And finally, one more thing that you will have to modify is the global file. It's this global file. And include all of the new buttons that you're gonna create into this type def struct. And at the end, go at the very beginning, and now that you have included them, also take them over with similar functions. Good luck!